I'm seeing you all after a long time. I'm fine, thank you. Hello, good afternoon. Nice to see you all too. Okay. Yeah, we're meeting after a long time. So today we'll do polynomials practice. I heard you all have exams coming up. Yes, it is raining here too. Okay. Not with gear. Okay. So you don't have exams. Okay, so I think the ones who had exams requested that we do polynomials practice today. So, okay, you don't have exams. That's nice for now. Good afternoon. Okay, so what we'll do is, so today we'll take up polynomials and tomorrow we'll take up number systems and we practice few problems. What I thought was like I'll just quickly give you all a what do you say, a note sort of a thing, right? You all can write it down and basically it will cover the entire chapter. What are the important parts of the chapter, how to solve, something like how to solve those important concepts. Okay, so we'll quickly go through that and then we'll do few problems, right? Okay, is my screen visible? Not okay. My screen is visible. Thanks. Okay, this Aditya Mundra, there's nothing like this session is exclusive. This basically we decided to take up practice instead of going ahead with linear equations because few of them have exams. So that's all. It's not exclusive or anything. All of you can attend. It'll be like a revision, right? Okay. Good afternoon, Ryan. Okay, so what I'm going to do is I'm going to quickly write down the things which are required for this chapter. Okay, so first off, the first concept which you come across will be to check whether it's a polynomial. Check whether it is a polynomial. Who can tell me how do you identify if it is a polynomial? This time you should be interactive. We're not doing anything new. This is going to be like a recap. So I want you all to be interactive. Answer, raise your hands, or yes, you can write it down. I'm just going to like make a short summary sort of thing. So when you try to solve, you'll quickly realize that how do you solve if this is given. It's basically just how to solve again. You write it down, you'll remember. Okay, few of you have raised your hands. Yes, let me see. Yes, Shivesh, can you tell me?
Ma'am, they can be a polynomial if they have variables and exponents, they all together.
Okay, but that's not the complete answer. Okay, so are you telling me is is this an exponent? I mean, is this a polynomial?
No, ma'am. Yeah, no,
Yes
ma'am.
or no?
No.
Why no?
Ma'am, because it's like it doesn't have any expression.
Huh? Expression as in?
Ma'am, I think it is a polynomial.
Okay, so you're confused now. Okay, how many of you all are going to say that this is a polynomial? Just raise your hand or just Okay, Vasudha says it is a polynomial. Uh, Netri says I don't know. Molly says no. Puneet has given me the right answer. Atharva also is giving me a right answer. Okay, so I think we'll have to go through the concept once. Okay, few of you are having confusions. So let me just go write here the conditions. Okay, what do you check when it's a polynomial? You check the power. Okay, oh, this is some multicolor pen, I guess. Strange. Okay, so you check the power. Okay, now if you see in this example, what is the power of x is half. So the power should be a whole number. You are going to be asked, like even in the workbook, there are questions, there are multiple questions. Ha, it is not. So Neki says yes, power is not a whole number. So what are you going to write here? So I'm just going to, erase this and write it properly. This is what I want you to write. Okay, I want you to write this. Yes. So the condition is you check the power. If the power is a whole number, it is a polynomial. So now it is not just the presence of a variable. Like x equals to 5 is a polynomial. 2x plus 3y plus z equals to 1 is a polynomial. Then x cube plus x square plus 2 is also a polynomial. So basically the power should be a whole number. That's the main important condition which we check here. Yes, Ria, yes. So keep that in mind. So when they ask you, check whether it's a polynomial, you are going to check if it's a whole number. Okay, so based on this, let's quickly see the exercise. Okay, so can you, will, shall we take up this one? 2.1.9. Quickly tell me whether the first one is a polynomial or not. You can just answer yes or no, but just for the first one. 2.1.9. Yes, okay. Anirban says no. Why does Anirban say no? Okay, yes, basically you got it. Okay, what about the second one? Somebody is saying no. Why is the second one not a polynomial? Atharva says no. Anetri says no. No. Why are you all saying no? Dhruv says no. Shakti says no. Okay, wait, we are on the second one. I'm just having, I need to sort it out since few of them are saying no. Okay, all those of you who are saying no, can you give me a reason why you're saying no? Root 2 isn't a whole number. Okay, so then maybe I should add another point here. So the power of variable should be a whole number. So basically, x plus root 2 equals to something 2 is a polynomial. So you're going to check for the power of the variable in this case. So it's y square, right? Y raised to 2. Y raised to 2, 2 is a whole number. So it is a polynomial. Okay. Yeah, you got confused because of the root 2. Okay, so basically, okay, what about the third one then? Now you tell me the third one. Third one is catchy. Yes or no? Somebody saying yes. Netri is saying yes. Shakti is saying yes. Are I just explained it. Mansi is saying yes. Okay, tell me what is the power of t? What is the power of t? Yes, Atharva got it finally. All those of you who are saying yes, I want an answer. Why are you saying yes? Okay, so in the third one, okay, Shakti, no worries. So, Shakti, uh, keep in mind this rule. Okay, how do you check whether it's a polynomial? First case will be there are two conditions you look for. One is the presence of variable like x, y, z, something. Okay, second thing you check the power of the variable. Okay, so what is the power of the variable in this case? It's 3 root t. 3 root t plus t root 2. So t to the power half. Half is not a whole number. So therefore it is not going to be a polynomial. Do you get it now? See, what is it? It is 3 root t plus t root 2. Ignore this root 2. This becomes a coefficient of t, right? So we are not looking at the coefficient. We are looking at the power. But so in this case, it becomes t to the power half, right? Or root 2. So this is not a whole number. Root will not be a whole number, hence it is not a polynomial. Is it okay now? Okay, got it. Nice. So then tell me the next one. Y plus 2 by y. Is it a polynomial? Hi? Yes. Raghav says yes. Alina says yes. Okay. Why do you say it's a polynomial? Mansi says yes. Ah, Shakti got it. Nice. Uh, those of you saying yes, may I know the reason why? Okay, guys, I think I need to go back a little bit more and cover something, some other part too. Okay, what I'll do is I'm going to quickly. Huh, okay, so there are a polynomial. Sorry, a polynomial. Suppose it's something like x plus 3y is equal to 4. Okay, so this term, you know, right? I'm going to put it as x square. Okay, so this and this term are the variables. In case anybody gets confused, please write this down. This is the constant, right? This number here, which you see, is known as the coefficient. In this case, it will be the coefficient of y, right? And this number which you see here is the power. Okay. So what is the first type of questions we encounter is check whether it is a polynomial, right? So now I'm telling you to check this. The power should be a whole number. This is power of variable. Should I say that? Power of the variable should be a whole number. Okay. Now is it making sense? Now what is the question? Y plus 2 by y. Is it a polynomial? So it is nothing but y plus 2y to the power minus 1. Do you still feel it's a polynomial now that the power of y is minus 1? Okay. Abir, maybe some connection issue. Can you refresh once? Yes, Neki, you have a doubt. Can you just raise your hand? I'll quickly unmute you. Yeah, tell me, Neki.
Yes, ma'am. I will say, you said in the previous slide, you told that another condition should be presence of variable. So,
Huh.
a constant like 4, will it not be a polynomial?
No, it will not be a polynomial. It will be a constant.
But
Polynomials start from like
power of
linear.
x is 0, and 0 is a whole number.
No. So actually, it starts from polynomials. Like there are. Let me just write it here. It starts from like linear, which has at least one. The degree of the polynomial is one. Then there is quadratic and cubic. Sorry,
So
cubic.
just a
Huh.
constant will
And
not
then
be called a
biquadratic.
polynomial.
No, no. It'll be a constant. Okay. So we'll take that up next anyway. So now tell me, now is anybody still confused about the fourth one? If it's y plus 2 by y, right? So the 2 by y में y का power will be -1. That's why it's not a polynomial. And the last one, quickly tell me last one. Puneet is saying not a polynomial. Why Puneet? I. Neki says no. Why no? Acha, for fourth. Okay. What about fifth one? Last one. Anybody saying it's not a polynomial? Okay. Acha, Neki, don't get confused. This is just asking whether it is a polynomial or not. So what do you do in this case? You don't go to categorize it like what type of a polynomial it is. All you see is whether the powers of each variable is a whole number or not. That's all. So in this case, it's x to the power 10, y to the power 3, and t to the power 50. Right? Uh, Polynomials in one variable. Okay. Yeah. Then yeah. If you are considering if it's in one variable, then yeah. Then it's not. Okay. Okay. So I think you got a hang of it fairly. What I'm trying to say. So this is done, right? So the next thing you come across will be types of polynomials. So what are the types of polynomials you come across? Linear, something like x equals to 5. There's only highest power is, let me write it here, highest power is 1. Then the next type you come across are quadratic, where something like x square plus 2x plus 1 equals to 0. The highest power is 2. Then you come across something like cubic, which is x cubed plus x square plus x plus 2. And last one is biquadratic. I'm not sure if you all are asked questions regarding this, but just for okay, in the bracket I have written the highest power, and these are the general types of polynomials which are formed. Okay, I'm not you know going to go in details because I'm not really sure. Uh, my screen is not visible. That's it. Okay. Let me just try. Okay, now you can see. Okay. Okay, so I'm not going to stress more on this part. It's just different, whatever, depending on the highest degree of x, there are different types of polynomials. Okay, so the, yes, okay. So we cleared the first type of questions you get. Let me see what are the next type of questions you get is, yeah, you get degree of a polynomial, right? So the second one which I explained just now. So first type is check whether it's a polynomial or not. Second type is they ask you the degree of polynomial. In this case, you look for the highest degree. Highest degree. What does highest degree means? The highest power, right? So we'll just take a, okay, if power is 0 then, yes, I'm writing something on the whiteboard. Is it not visible? Should I try again? Okay. Now is it visible? Just try once. Those of you who are facing a difficulty, just try refreshing your connection once because few of them can see. Okay. Okay, Raghav has something, some question. Yeah, sure, Raghav. Give me a minute to. Yes, hi, Raghav.
Ma'am, you
Hmm.
said that the types of polynomials are linear, quadratic, those, but then aren't the types of polynomial monomial, binomial, trinomial, and polynomial?
That also. It is the same thing. In monomial, you will have one variable. In
Yeah,
binomial, you will have like, so 2
two.
degrees. So it will be x square plus will be nothing but a binomial equation. So
So if we write
based on the,
cubic or trinomial, it's the same, right?
huh,
Okay, thank you.
okay. Is my screen lagging a lot? It must be the network, yeah, sorry. Must be because of the rains or something. Okay, so yeah, so the second type of questions you get are, uh, okay, I think people are having a doubt in cubic and monomial. Okay, let me quickly see your CN. Give me a minute. Okay, so what does it say? Types of polynomial based on degree, right? So this is what I was explaining that time. Based on degree, it will be constant, linear, quadratic, cubic, and biquadratic. Okay, and now based on the number of terms, it's going to be monomial, binomial, trinomial. Okay. So okay, got it now. So what I was explaining to you, the linear part and all that. Yeah, sorry, my bad. I got confused a bit. So yeah, they are not the same thing. Raghav, right? Raghav had asked me the doubt. So what why I was asking you, I was telling before, like linear, quadratic, cubic, and biquadratic come under the basis of degree. So this classification falls under degree of polynomial. And what you guys are saying about monomial, binomial, trinomial. Monomial has a single term like 5i. Binomial has two terms. Actually, they don't ask you much. I am not seeing that many questions regarding monomial, binomial, or something like that. It will be 3x plus y. This is a linear equation, but it is a binomial. Aditya Mundra, can you check your connection once? Maybe some connection issue. Monomial, binomial, trinomial has three terms. That's all. Okay, this is on the basis of number of terms. Let me write it here. Okay, now I hope there's no confusion. Yeah, I got confused. So this is based on the number of terms. This is based on the degree of the polynomial. They both won't be the same. Okay. Hmm. Okay, so this question I was talking about is, yeah. So the next type of questions you get are what is the highest degree, like in this case, like in the very first question of the WB, which says find the degree for each of the polynomials. So tell me, what is the highest degree of the first one? x5 minus x4 plus 3. 5. Nice. Yes. Okay, this part is easy. Correct? Yeah. So if they ask you find the degree, is you look for the highest power of x or y or whichever variable it is. Yeah, second one is 8. What about third one? Third one is 1 or 0. Trick question. Third one is 1 or 0. Somebody is saying it's 1, some are saying 0. Come to a conclusion. 1 or 0. It can only be 1. I mean, one of the answers, not 1. Okay, I see few of you are having doubts here. Let me clear it for you. Okay, so the equation is like 2, right? They're asking you highest degree of the polynomial in 2. So this is nothing but x to the power 0 is equal to 2 or y to the power 0 is equal to 2. So the degree is going to be 0, right? If the degree was 1, there would be x there in the equation, in the polynomial. Yeah, anything raised to 0 is 1, but we are asking the power. We are not asking what the anything raised to 0 is. Right? Don't get confused. If you are going to say the highest degree is 1, which means x is equal to 2 is the polynomial declared. This is when the highest degree is 1. When it's 0, it will be 2. When it's a constant, the highest degree or the power is going to be 0 always. Clear? Any doubts or clear? Okay, so I hope you are, taking this down somewhere. The different kinds of problems I'm clear. Awesome. The different types of problems I'm talking about, right? So the first type we discussed was the first type of problems are whether it is a polynomial or not, right? The second type is going to be the degree of a polynomial. They'll just ask you degree. It automatically means the highest power, right? Okay, nice. So then we'll move on to the next concept. So once you're done with this, the next thing they ask you is third part. Find the zero of a polynomial. These are the other type of questions you come across, right? So basically I'm talking about all the different kind of questions you will come across in this chapter. And I'm just giving you tricks or tips on how to solve them, right? So that any confusion is there, even now, you can get it cleared once and for all. Okay. Okay, Raghav, tell me. I'll just unmute you. Tell me what is the issue. Okay, third one. Can you raise your hand, Raghav? I'll just unmute you. Acha. Okay, Raghav has a question in the identification of polynomials, the third one. Y plus 2 by y. Okay. Yes. So you have a doubt as in what is the. Okay, you want to know why is it not a polynomial. Okay, so y plus 2 by y is nothing but y to the power 1 plus 2 y to the power minus 1. You have done exponents, right? In number systems, I believe. Laws of exponents, how do you write them? So basically if a variable is in the denominator, it can also be written like this. It can be written like this, which is nothing but it will be in the denominator, the power 1. Right? So it gets a negative power if you try to take it in the numerator. So basically the power of y is 1 and minus 1. So because of this minus 1 here, it's not polynomial. Okay. Okay. Raghav got it. Nice. Okay. So the third concept, can anybody tell me Oh, I hope you all guys are familiar with all this, what I'm saying, and it's not like, you all are lost or finding it hard to understand. Tell me, how do you find the zero of a polynomial? Very easy, nice. Okay, huh? Can I tell? Okay, Neki wants to tell. Yeah, Neki, can you raise your hand? Uh, uh, uh. Hi. Where is the question? Okay, Puneet, the question is, how do you find the zero of a polynomial?
Ma'am?
Hi, Neki. Hi, yes.
Yeah. So I was saying, for a polynomial, for any polynomial, in which the value of x or value of the polynomial, when we substitute, it gives the answer as 0. So that value is called the zero polynomial.
Uh, okay, I am not going to say I completely agree with that answer because uh, it's not when you substitute a value you get 0, it's when you substitute 0 and the value you get is the 0 of the polynomial. It's the other way
Yeah,
around.
yeah, but I was saying yeah, kind of.
Ha, you got confused. No worries. It's okay, it's okay. Okay, so don't, okay, for this part, I see most of you are giving me theoretical, big definitions, answers. It's very simple. Yeah. Okay, Neil, awesome. Neil has given the good, short and sweet answer, right? What do you do to find a zero of a polynomial? What is it's there in the statement itself. So suppose your polynomial is something like x minus 1. Say this is your polynomial. So when you need to find the zero of a polynomial, very simple, just equate it to 0. When you equate it to 0, x becomes 1. So x equal to 1, this thing, this term, or this equation is known as the zero of a polynomial. Where x is 1, or you can say 1 is the zero of a polynomial, anything. Okay. Don't go to by heart big definitions where we substitute the factor. No, 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 Puneet. No, no, not such big definitions. It's very simple. Just equate the polynomial to 0. You don't have to substitute anything anywhere. You are getting confused, I think, with remainder theorem and those parts. I'm just asking. Yeah, Atharva is given a good example. Yes. So it's very simple. You are going to be asked questions for like 1 or 2 marks, which is directly find the zero of a polynomial. So just note all these things down or whatever. You can refer to the recording later, but make sure you have this somewhere so that when you're studying, this like for a quick recap, you can just look at these things. You don't have to keep hunting for definitions or oh Shakti, this was an example. We don't use minus 1 always, we don't use. Okay, so suppose if your polynomial is something like 3x plus 2 equal 3x plus 2. Okay, now they said find the 0. So what I'm going to do, step 1 is equated to 0, right? Step 2, find x. So it will be nothing but minus 2 by 3, right? So this expression right here which you have got, so this term is known as the zero of a polynomial. Okay, any doubts? Anybody still having doubts in this concept? Puneet, check, it will be minus 2 by 3, not 3 by 2. Okay, Puneet has given his own example. Okay, yes, right. So you don't have to, like in the exam, they are not going to ask you theorems. They are not going to ask you what is the procedure to find zero of polynomial. They're just directly going to give you sums, right? So just remember the simple, shortest way of doing it, which is find the zero. That's it. See the equation, equate it to 0. Whatever the polynomial is, just equate it to 0. Okay, let me see how well you got this thing. I'm going to ask you a question. Okay. What should I ask? Let me search. Okay, I can see only a simple one. Okay, what I'll do is I'll just create a known question or something. Okay, tell me this one. Find the zero of the polynomial 2x plus 1. Maybe later when we glance through and we come across something more difficult, we'll take up that. 2x plus 1, find the zero of the polynomial 2x plus 1. It's very simple. Awesome. I want all of you to answer. Nobody should be left out. Yes, nice. Awesome. I see half of you all have answered already. Yes. Okay. What about the rest? Yes. Yes. Vansh, Muskan, Dhruv. Yes. Sarah. Nice. Okay, Jimmy. Jaden, Jimmy. Yes. I haven't seen you answer before. That's nice that you answered. Okay. Yes, Arav. Yes, I want all of you to answer so that I'm, 100% sure you've got this concept. This should be like this time it should be fixed in your head that what do you do when you're just asked find the zero of a polynomial. Shivesh, yes. Okay. So I think I've got answers from everybody. So what I'll do is when we glance through this workbook, once I finish the different types of questions, if we come across something, I'll ask you. Okay, so we finished the third type of question. So these three types which we took up right now, which is basically identifying whether it's a polynomial or not, then identifying the degree and finding the zero. These questions, I guess, might come only for 1 or maximum 2 marks because they are very straightforward and pretty simple, right? Okay, so now we come to the ones which are difficult, let's say. What do you say? They are a little bit difficult to get hold of, but with practice, you are going to get good at them. So, long division. The next type of question is long division, right? Wherein you are given a polynomial p of x has to be divided uh, by, say, let's say g of x, right? Such type of questions. You perform long division, right? Somebody has a doubt? Or tricky? Yeah, Abir, yeah. These are a bit tricky. So we covered the easy ones first. Now we are going to a little bit tricky level. So we'll keep doing difficult. We'll keep increasing the difficulty level. Okay. So for this, I want you all to remember this one statement which I write here. Write it as it is if you like, or you know. So, oh, why did it not change color? Okay. So what I am interested in is this kind of a equation. Okay. This is called the dividend. This is called the divisor. This is called the quotient, and this is called the remainder. Okay. I want you all to memorize this term, this equation. Okay. Somebody has a doubt? Yes, Athara, yes, I was aiming for this. And okay, so in long division, how do you say? Shall I take an example? It will be better, right? If I take an example. Okay, so I'm just going to pick some question up from here. Okay, let's take up this question. By actual division, find the remainder when x power 4. Okay, let me just minimize the screen and write it here. Okay, awesome. Okay, so it's what? It's basically x power 4, yeah, minus 2x square plus 6x plus 3 is divided by x minus 2. So in this case, this is your divisor, this is the dividend, right? The term which you will get here will be your quotient, and what you get after dividing, if you get a term here, this will be your remainder. Okay, keep this in mind. This will be helpful, useful later on too. Right. No, this is not remainder theorem. So there is a concept before remainder theorem which is long division. I am talking only of long division. I am not focusing on anything else. We'll go stepwise. We'll cover long division, then we'll go to remainder theorem. Okay. So can you solve this for me? Who's going to solve it for me? The question is on the board. I want you all to perform long division and tell me what is the quotient and the remainder. What is the question again? 1, 2, 1, 2, 3. Yeah. Not possible. Why? Abhi, why is it not possible? Okay, Raghav, yes, can you tell me the remainder also? What happened? Are you guys stuck somewhere, or is this like you've forgotten a bit of polynomials, or what is the, or are you solving? Remainder, Raghav, what about the remainder? You get a remainder. Okay. I'm getting different answers for remainder. Okay. Huh? Shakti has some completely different questions. You can't subtract. Remainder 23, 2 minutes. Okay. Okay, I am sensing there is quite a few of you who are stuck. I don't know why I feel that, but okay. So let's do one thing. I'll take up this question. Okay, and then I'm going to give you guys one more to solve. So let this be like a recap. What is the, we just copy it. So I'm going to add, there is no x cube term, so let me just add an x cube term, minus 2x square plus 6x plus 3, right? And I have to divide it by x minus 2. Okay, so what do you do first? First you aim to get this term. All those who are stuck, please follow this carefully. I'm explaining this long division once, right? Then I'm going to give you a question to do on your own. So to get x power 4, what will you multiply with x? You multiply with x cube, right? You'll get x power 4 here. Okay, then the next term will be minus 2x cube, right? So now I'm going to perform subtraction. There'll be sign change. This will get cancelled. You are left with 2x cube minus 2x square. So now I want x cube. I am going to multiply with plus 2x square, right? So I'm going to get 2x cube minus 2 2s are 4 minus sign, right? Minus 4x cube. There will be sign change, right? This will get cancelled. 4 minus 2 will give you 2x square plus 6x, right? So for 2x square, I need to multiply with 2x. So 2x square, this is going to be minus 4x, right? Let me just take the screen a bit. Yeah. Okay. So this, I'm going to do sign change here. This term gets cancelled. You are left with 6 and 4, 10x plus 3, right? I am going to, for 10x, I'm going to, yeah, multiply by 10. So I get 10x minus 10 twos are 20. Sign change plus this gets cancelled. You are left with 23. So this is how you do long division. Everybody is getting a different remainder. Why are all of you getting different remainders? Minus 1, somebody says 49, somebody says 5, 23, minus 1. Huh? Molly, minus 1 is, what is minus 1? Nikki, yes, yours is right. Okay, you subtracted in place of adding. No worries. I think you guys need a recap. Yeah, you needed a recap, so no worries. It's okay. You get it. So if you are stuck somewhere, just copy this down. I'm going to give you a new question to solve on your own. Right? For now, just copy this down. Remainder is minus 1. Molly, how are you getting minus 1? Yeah, Puneet, that's right. Molly, are you stuck somewhere? Are you having a doubt somewhere? Yes, Sarah. Remainder is 23. No? Okay. Okay, so this, you got your mistake. That's nice. Good. Okay, so what, yeah. So this is the fourth type of question which you get in this chapter, which is nothing but long division, where they will give you a polynomial and say divide it by that, right? So this is, or they will ask you find the remainder when an expression, should I just write it here? Or, okay, this will be asked, or they'll ask you find the remainder when divided by g of x. Okay, so this is, Abhishek, can you check your answer once the remainder is 23? You are making a mistake somewhere. Okay, all those of you who are stuck, you can refer to this later and rectify your mistake or try solving it on your own and check where you gone wrong. We'll go ahead to the next kind of questions. Okay, so this is long division. I'm going to solve everything, like different kinds of questions, but first I want to cover the different types of problems which are there, and then we will solve. Okay, so that was long division. So now next one which we come to is a short way of solving when they ask you find the remainder. Find the remainder. Or they ask you use remainder theorem. Right? This is the next kind of question. I want you to remember one very important thing here. Okay, what is that important thing going to be? Is that this is applicable only when you are dividing polynomial. Oh, okay. Linear polynomial. Okay. So this is the important thing I want you to keep in mind. It's lagging. Oh, everything is lagging. Is it fine now? I think because of the rain, there is some network issue. Yes, Mansi, I'll take up another sum on long division. I'm going to take up sums on all of these. Just let me quickly, finish the types of sums which you get. Otherwise, that will be left out. It's lagging. Sorry. Uh, what can I do? Okay. Okay, just try to see if, you're able to catch up, or maybe then you can refer to the recording later. Or what I'll do is, I'll just write this. Rain is, yeah, the rain is there. Yeah, because of the rain, there is a connection issue. I agree. Uh, okay, what I'll do is I have an idea. Just see if you can, note all these things down now. Or what I'll do is I'll write it in a. Okay, you want me to switch off my webcam and see? Okay, let me do that. Okay, yeah, I've switched off my webcam. Maybe it is better now. Yeah, I am not writing anything, Neki. It might pick up. The connection might be fine. So don't worry. What I'll do is audio connection has been lost. Okay. Yes, I have. I haven't written anything after linear polynomial. I'm just waiting for this connection to. Okay, can you all refresh your connection once, because few of them it's fine now, but few it's not here. Flagging. Okay. Now it's fine. Can you all refresh your connection once? No, I have not written anything after polynomial. It's just I'll just shift this screen a bit. Okay, is this fine? Okay, so I was talking about the remainder theorem. Better now. Awesome. Okay, I was talking about the remainder theorem. So in that, I want you to keep in mind an important concept, that it's applicable only when dividing a polynomial with linear variable, which means what? What does this imply? What does this imply? That g of x should be a linear equation, right? That's why I made you all write down p of x, g of x and everything, right? So what do you do in this case? Again, they are not going to ask you. Okay, I'm sorry. I think it's because of the rain. Maybe my network is messed up. So don't worry. I'll do one thing. I'll just write these points down somewhere, or try to share the recording as soon as I can. Okay? So you won't miss anything. So don't worry. Don't. Okay. Okay, so g of x here, this means that g of x should be a linear equation. Again, don't go to memorize big words, big theorems, because 99% they are going to ask you direct problems, right? They're going to say use the remainder theorem and find the remainder for this polynomial. So Just remember how to solve it. How do you solve it is you will be given P of X, which will be your dividend, and you will be given something it has to be divided by, which is your divisor, right? G of X. So steps to be followed, uh, equate G of X to 0. Basically, this is nothing but finding, should I write it here? Finding the 0 of G of X. Okay. Whichever way you feel easier to remember. Not lagging anymore. Awesome. Hey guys, don't worry. I'll ensure to send the recording as soon as possible. So don't worry. It'll be fine. If you're not able to catch up right now, don't worry. Okay, so equate g of x to 0 will be the first step. Then the second step will be what? You find the 0 of g of x, right? Then you substitute that 0. Okay. Substitute 0 of g of x in p of x. Okay. Yep, substitute. Awesome. So whatever answer you get, answer is the remainder. Okay, you can write these steps down. These are the steps, right? This is just a short trick of doing it, or short easy way of remembering what to do. So don't get confused or lost when you see the words remainder theorem and then be like, oh, what is the remainder theorem? Very simple, just break it down. Remainder theorem means they want you to find the remainder. How will you find the remainder? You equate g of x to 0. Then you substitute that value in p of x. On solving, you will get a constant. That constant will be your remainder. And this is applicable only when g of x is a linear polynomial. Okay, Netri has a doubt. Let me unmute you. Yes, hi.
Hello, ma'am. Can you hear me? Ma'am, can you hear me?
I can hear you, Netri.
Yeah, ma'am, I had a doubt that as you told that g of x should be g of x equals to 0 and it should be a linear equation, like a linear polynomial. So,
Huh?
like, what if like the highest degree is 2, then 2 the
Oh,
g of x can be like equated, right?
if the highest degree is 2, then you will get it in the form of a quadratic equation, right?
Yeah,
Or
ma'am, for
then you can
example,
use.
I'm asking like if g of x equals to x square minus 9. So then like the value of x will be the root of 9, that will be like, for example, if there is a sum like that.
What you're saying does make sense, but in general, it is for a linear. This theorem is applicable only when g of x is a linear polynomial. Even though there might be cases like you're saying, but
Like
it's
in the exception,
applicable.
right?
Yeah, that is like an exception, and I don't think that will come. If you encounter such problems, they might fall under long division. So if it's anything other than a linear polynomial and they ask you to find the remainder, you might have to perform long division to get the answer.
Okay, ma'am. Thank you, ma'am.
Oh, yeah, no problem. Shakti has a doubt. Yes, Shakti, can you raise your hand? I'll just unmute you. Ha, tell me.
Ma'am,
Yes.
Sometimes in the question they've already given the 0 of g by x. So can you use that then?
Yes, definitely. If it's already given, then yeah, that makes it easier.
Okay, ma'am. Thank you.
Okay. Raghav has. Okay, ma'am, can you give us some that does not tell if we have to solve by remainder theorem or factor theorem? That does not tell. Okay. Then that will fall under. If it does not say, then you can perform long division and get it. Right? So basically, if they specify use remainder theorem, it's shortcut way of doing it. Actually, it's a short and simple way of doing it. But if they don't specify remainder theorem, you always have long division to get the quotient or the remainder. If they say it's a factor, which means the remainder will be 0, so you get the quotient, right? And if it asks only remainder, then remainder theorem. If they ask for quotient also, no, Atharva, see, if they, what the kind of question you might get is they might just ask you find the remainder. Okay, they are not going to give you a hint that you can use remainder theorem. They might just say find the remainder and give you a polynomial. Okay, let me show you. Somewhere here. Okay. Find the value. Hmm. Okay, yeah, like for this question itself, find the quotient and the remainder of the following, right? If they give you question like this, even though you see here, if you see here, g of x is a linear polynomial, right? It's x plus 2, highest degree is 1, which means it's a linear polynomial, which means you can perform remainder theorem. You can use remainder theorem here, but they have asked you for the quotient too, which means using long division is a better idea, right? Because you will get only the remainder via the remainder theorem, which is not going to be useful. That's just half of the part of the answer, right? So if you do long division, you get both. So these two questions, it will be advisable to do long division. In other cases, you might be asked by actual division, right? See, it's mentioned in the next question itself that by actual division find the remainder. Even though, see, here also g of x is a linear polynomial. And then you might get questions where they ask using remainder theorem, right? And the highest level means the highest level of tricky question will be, I'll just show you. There might be one. Yeah, here it is. Find the remainder obtained on dividing p of x by x plus 1. So here you have to check. So if you look at it closely, g of x is again x plus 1, which means it's a linear polynomial, which means you can use remainder theorem here, right? So you have to, uh, think a bit and figure out that which will be a better way to use. What will be a better way to solve the question? Okay, got it. So there will be, do you want me to write it down? Like, what are the type of questions you get? Or do you understand what I'm saying? Should I write it down or is it clear? Like, anybody still having doubts how to find the remainder if they don't, like, if they're not specified or understood? Nice. Okay, what I'll do is I'll just repeat once in case you have doubts. So they might ask you different type of questions, like they might be asking you saying find the quotient and remainder. When they ask you quotient and remainder, always use long division, right? Second case is they might directly say use actual division and find the remainder. Again, this method you have to use long division. A third case, they will tell you use remainder theorem. They'll give it to you. Okay, they'll tell you what method you have to use. Then they'll say use remainder theorem, which means you have to use that and get the answer. If you do long division in such questions, you'll lose your marks. If you do remainder theorem in place where they ask actual division, again you lose your marks. Okay, so just be careful on what they have asked. And the last type of questions will be they will just give you like in this case, like this question here at the end, they say find the remainder obtained on dividing p of x by x plus 1, right? So this they have not specified either long division or remainder theorem. So in this case, you have to take a choice. This decision is left on you. Which method you find it easier. Always resort to the easier one, right? Because you don't have much time to perform both the methods, or don't do such things, right? Always take up the easy one, which is the remainder theorem, the quickest way to do, because all the mistakes which are possible while doing long division can be avoided, right? So if they don't mention, and if you see that you can use remainder theorem, always resort to that. Okay, so that's it. Sorry, that's it about remainder theorem. So these are the steps. You got it, right? Should we solve a question? Let's quickly solve. Okay, tell me this question itself, 2.2.3. Find the remainder obtained on dividing p of x cube plus 1 by x plus 1. Use remainder theorem and tell me. Awesome, Netri and Dhruv have answered. Netri, Dhruv and Vasudha have answered. Abir has answered. Shivesh has answered. Awesome. Which is the question? Okay, the question is 2.2.3. Yes, I can repeat the question. Rakshita, Abir, Neil, awesome. The question is find the remainder obtained on dividing p of x cube plus 1 by x plus 1. It's 2.2.3 in case you have your workbooks. Awesome. Arav, Puneet. Anirban, how did you get that? Atharva, Aditya. Awesome. Okay, so I see this method you got a hang of it. Nice. Yes, Atharva, that will be like one more step ahead what you're saying. The rest of you, are you solving? Have you solved? Are you stuck? Can you tell me what's the status? Elena, no, I don't think I got your answer. Shakti is solving. Mansi, yes, I got your answer. Elena, I did not. Oh, now I got your answer. No, Elena, can you check once? What do you do here? You do x plus 1 equals to 0, right? X plus 1 equals to 0, so x is equal to minus 1, right? Then you substitute x equal to minus 1 in p of x. Nothing but minus 1 plus 1, 0. Yes, Sarah, your answer is right. Anirban, yes, you got it now. Okay, got it. I think this is easy, right? Remainder theorem is easy, right? Just remember the steps. Yes, okay. What are the steps? Just remember that. Don't go to memorize what the theorem says and those complex sentences and then. Elena has a doubt. Okay, Elena, can you raise your hand? I'll just unmute you. Hi, Elena.
Ma'am, can you hear me?
Yes.
So ma'am, in this question, p of x is equal to x square plus 1, right?
It says x cube plus 1.
Oh, sorry. Actually, I thought it was x square. That's why
Yeah, maybe that's why the error. Yeah, sorry, maybe it's not quite visible. It's x cube plus 1. Okay, so remainder theorem. pretty easy. Yeah, these are the steps. Write this down somewhere. Okay, so when when you open the workbook to solve, when you are looking through variety of questions, you pinpoint to which part of the question, which type of question it comes under, and you know what are the steps. So you don't feel lost. This will help build your confidence, right? We don't want you feeling lost that, okay, I opened the book, I saw the sum. Ryan has answered. Yes, Ryan is correct. Yes. Shivesh, how did you get one? Check again. Okay, so just please, I hope you all are noting this down, or I hope you are going to note it down after seeing the recording, whatever. But please keep this somewhere in your book so that you have it with you when you're solving. Okay, so the next step question is, what is it going to be? It's we'll take a factor theorem. So it's sixth, right? Factor theorem. Basically, in this, you need to show that g of x is a factor. How will you show? How will you show g of x is a factor? When you substitute 0 of g of x in p of x, you should get 0, or in other words, remainder should be 0, right? Yes. Oh, awesome. I'm happy. Shivesh. Uh, Abir and Elena are giving me answers. That's right. So yes, the shortest way of remembering this is that remainder is 0, right? So, but now factor theorem is used. There are two applications of this theorem. We'll tackle both of them. First case is when you get questions where they'll ask you, check if g of x is a factor, right? And the second type of questions is you use is factorize using factor theorem, right? So these are the two questions, type of question. Oh, hmm. Okay, so we'll take this up one by one. So first wala part, check if g of x is a factor. What do you do? What will be the steps? Again, same thing. Steps 1, equate g of x to 0, right? Then substitute 0. Okay, I'm going to write the words. Substitute 0 of g of x in p of x. Answer should be 0. Okay? Clear? Awesome. Yes, Atharva. This is easy. Okay, I think you guys have a fairly good hang on remainder theorem and factor theorem, isn't it? So not so tricky. I thought these two must be the trickiest ones. Yes. Okay. Okay. And what is the very easy, right? Okay. So, okay, let's see. So easy now. I'm going to ask you all to solve. I want all of you to solve then, right? Could you explain the factorized one? Yes, sure. Okay, so factor theorem basically what? Oh, is it zooming in? Okay, so hmm, sorry for the. Yeah, so factor theorem basically is an extension of, or you can say is like a part of remainder theorem. What do you do in remainder theorem? You find the zero of g and you substitute it in p of x, and whatever the answer you get is the remainder, right? But in this case, it's already mentioned, like, if it's a factor, the remainder is going to be zero, right? So the same thing you're going to do, but you are going to, look at the answer and see if you get a zero. Instead of finding the remainder, you check whether you get zero or not. That's the only difference. So you're going to do the exact same things as remainder theorem, same steps. But if you get a number other than zero as your answer in the end, it means it's not a factor. Okay? Is it making sense now? Okay, awesome. Alina, is it making sense? Are you able to figure out now? Yes? Okay. So just remember, all of you, remainder theorem and factor theorem are like very close. Okay? Remainder theorem may you need to find the remainder. Factor theorem may you need to show that the remainder is zero. That's all. Is the difference. Both have the same steps, right? The only difference is in factor theorem, your answer, your remainder, if it is zero, that means g of x is a factor. You just need to add that one statement. Like I think Atharva had mentioned in the previous question, he said, right? Because we got the remainder as zero that time. Okay, so this is one type of questions you come across for factor theorem, and there is another question, right? There is another type of question which is factorized using factor theorem. In that you will be given an expression like ax square plus b ax square plus bx plus c, right? So this is the way a general way of expressing a general form of quadratic equation, right? This general way. Suppose you are given something. So this method, right? This is like a trick. So normally if you get this question factorized using factor theorem, you will be 99% given a quadratic equation, right? In the highest level of tricky question, I'm going to give this question to you to solve, right? This there you need to use identities and factorization to solve. That is the highest level of difficulty. But generally they'll ask you questions where a quadratic equation is involved. So what do? First step. Should I just like shift the screen up a bit? Okay. Huh. So here the first step will be to make coefficient of x square 1. How do you do that? Is by dividing throughout by x by a, right? So it will become plus ca, right? Always make sure you do this step. If there is no coefficient of x square, then just directly proceed with step 2. But in case there is a coefficient of x square, always do this, right? The first step, make the coefficient of x square 1 by dividing throughout by the coefficient of x square. That's all. Then next step is what? Find factors of the constant. Find factors of c by a or constant. I'll take up a question so that this doesn't seem difficult, but this is like a general way of doing it, so I'm mentioning these steps, right? You find factors of c by a. Third step, use trial and error method to find zero of equation, right? So just make a note of this. I'm going to quickly take up a question and explain it to you how to do this, right? I'm not focusing on factor theorem because you said it's easy, so I'm going to discuss steps which which are difficult, right? Okay, so you noted it down. Can I take up a question? Okay, yes, okay. Huh. So let me take up a question. Huh. We'll take this one. Okay, or should we take, wait, I had written, okay, we'll take this one. Factorize y square minus 5y plus 6. Let me, okay, what is the question? Factorize y square. So it says factorize y square minus 5y plus 6, right? Using factor theorem. It says very specifically. Using, I'm just writing FT here in short. Okay, this is the question, right? So first step, check the coefficient of y square. It's already 1 here, right? So now what I'm going to do, I can neglect step 1 because its coefficient is already 1, right? So I'm directly jumping to step 2, wherein I find the factors of 6. So how do you find factors of 6? They are 1, 6, and 2 and 3, right? 6 into 1 is 6, 2 into 3 is 6, right? No other factors. Okay, so now we do trial and error method. Other factors will be something you multiply to get the digit. This is not splitting up the middle term. This factors of 6 means which numbers do you multiply that you get 6, right? That is basically a factor of a number. Don't get confused. Okay, so now I'm going to do trial and error method. So what does this method involve is I am going to uh, just substitute, like just find each factor one by one. So let's take 1 first. So I'm going to put the value of 1 in p of x. So that will be 1 square minus 5 1 plus 6. This is 1 minus 5 plus 6 is what? This will be 6 plus 1 7 minus 5 2, right? So not a factor. I want this answer to be 0, only then it will be a factor, right? So I'm going to check for 2, p of 2. P of 2 will be 2 square minus 5 2 plus 6 4 minus 10 plus 6. This is 0. This is a factor. Then p of 3 is 3 square minus 5 3 plus 6. Let me just take the screen a bit up. Or 3 square, right? So 9. 9 minus 15 plus 6. Will only have 1 0. Middle term splitting. Yes, you can use middle term splitting when it is not mentioned using factor theorem or when it is mentioned using splitting the middle term. There are cases when you will get questions which say factorize using factor theorem. So you need to know what you have to do, right? Yeah, Netri has already given me the answer. Good job. Okay, so we can stop here. We don't need to find for 6. We don't need to perform these steps for 6 because we've got the 2 zeros, right? Keep this in mind. Should I write it somewhere like here or something that for linear, you will have 1 0. Okay, it's not taking it there. Oh God. I'll write it here. This is like a trick to remember, so you know how many zeros are there or when to stop. Okay, linear equation will always have 1 0. A quadratic equation will have 2 zeros. Okay, so you can stop. So we got 2 zeros, so we can stop here. And how do you write it as? So always when you get the factors, they will always be written as y minus 2 and y minus 3 is 0. So sometimes you might have to, in some tricky questions, see, like here we only consider the positive cases, right? Sometimes you also need to consider negative cases. In those cases, this will be plus. So it will be if you are checking with, say, using, I'll write it here. Yeah, say you're checking using p equals minus 1, right? So it will be minus 1 square minus 5 into minus 1 plus 6, or it will be 1 plus 5 plus 6. It's nothing but 12, right? So it's not a factor. But in case if it was a factor, you will write it as, sorry, not p, it will be y. So it will be y plus 1. It's lagging a bit. Right? This will be a factor if it was. Okay, I hope you got it. Can you give example where coefficient is not 1? Sure. Did you get this? What? Did you understand what I am trying to say? How to solve this question? I will take it up. I'll take up one question where it's not 1. Okay, awesome. So let me see one question. Here, there are multiple questions here. Factorize, right? So see, it just says factorize. It does not say using splitting the middle term. So like you have two ways of finding remainder, either long division or using remainder theorem. Similarly, you have two ways of factorizing a given equation. One will be splitting the middle term, another will be factor theorem. In this case, in the first case, remainder theorem is easier. In this case, splitting the middle term is easier, only if you know how to do it correctly, because factor theorem involves trial and error method, which is time consuming, right? Why did I solve with p equals to minus 1? Okay. Puneet, that was just to show that this final step here, like I just showed you, this step here of writing the factors. How do you write the factors, right? uh, how do you write the factors? So sometimes there may be factors which are negative also. So when you have something like if p of minus 1, suppose we got this as 0, then you write it as y plus 1. So I wanted to clear it that if the factors are positive, you would write it as y minus 2 or x minus 2, whatever the variable is, the initial variable is, right? Only if in case you are using minus terms, then you write it as plus. So you write the factors as plus. I just wanted to clear that. For that I took it up. Okay, so we'll take up an example here. What should we take up? Let's say this one itself. We'll take up the second one. So the second one says, let me clear this. Okay, so the question is 2x square plus 7x plus 3. 2x square plus 7x plus 3, factorize. Right? So now if you see x square has a coefficient here. So step 1 is to get rid of the coefficient. How do you do that? Divide throughout by that coefficient. Right? So now we search for factors for 3 by 2. 3 by 2 factors, you search for 3 of them. So that can be, wait, let me see. So it can be 3 into 1 by 2, or it can be 1. 1 will always be a factor because 1 into 3 by 2 will give you 3 by 2, right? Or it can be, there can be so many factors here. I can even say, what should I say? 3 into 1 by 2 can be 1. Then there can be more, right? So basically, yeah, so this case there will be a number of factors, quite a number of factors. So how can we factorize x cube minus 2x square plus 2? Yes, you can use, yes, Puneet, here you can use splitting the middle term, right? Because it does not say anything. So you can use any method you like. Dhruv wanted me to take up a question where the coefficient of x was not 1, so I just showed you how to do it after this. Right? Mansi is asking how can we factorize x cube minus 2x square minus x plus 2. How can we factorize? I think you can. Okay, it's a cubic. So for this, this there is like a way to solve these things. So first it's like okay, I'll show it to you what to do. So it's x cube minus, let me see, what is that question? This is like the highest level of difficulty problem. So this involves using both factor theorem and splitting of the middle term. So like there is one question, like it's in level 3. I didn't want to touch it right now because you all might get confused. But there is a question which involves x cube. It's something like x cube minus 23 x square plus 142x minus 120. Right? Let me just. Okay. So in this case, what they have done is when you are given such a question where there is x cube. So first you find the factors of 120. Okay. Yeah, another thing to keep in mind, no, always when you say factors, na, consider plus minus. So plus minus 1 plus minus 120. You most of the time the minus part is not really does not applicable. Most of the time you need to consider only the positive factor, but it's a good practice to write a plus minus 1 plus minus 120 so that that there is a chance that the negative part could also be a factor. Right, there is one question in the workbook where you have to take I think it's somewhere in level 3 only, that you have to consider negative part and then you get it. It's there in yeah, it's there in level 3, 2.3.2. If you see, it's solved both by splitting the middle term and factor method. So there a minus factor is used. Okay, so first you find the factors like this and then you try putting one of them, like here if I put p of 1 be 1 cube minus, okay, sorry, so it will be 1 cube minus 23 1 square plus 142 1 minus 120, right? So it will be 1 minus 23 plus 142 minus 120. This basically comes to 0. So from here we can say that x minus 1 is a factor. Okay, so we've established one of the zeros, so there will be 3 zeros. Since it's a cubic polynomial, there will be 3 zeros. Didn't understand? Okay. Yeah, so this is actually a high level question. This is the highest level of difficulty question, which I'm not really sure you all are asked this, but since one of you asked how to solve it, I was just trying to show it to you. So I don't know if you are asked such kind of questions in the exams. Yeah, now see, now you got one factor. Okay, for all those of you who did not understand, generally the questions you get have the highest degree as 2. Okay, you were asked this question. Oh, okay. So the highest degree generally you get to factorize is 2. In the highest level of difficulty is they might give you a cubic polynomial and ask you to factorize. In that, what do? First, see the last term. Okay, it's the last term here. So the constant term. Okay, find the factors for that. So there will be plus 1, plus minus 1, plus minus 120. Then you can do 60 into 2 or 220 into 6 and so on. There will be a list, right? So you can mention the whole list like, okay, plus minus 60, plus minus 2, plus minus 20, right? The whole list will be there. So the convenient one to start with is 1. So we started with 1 and the remainder was zeros. Hence we know that 1 is a factor. That means x minus 1 is a factor. The next step what they do is they write the this equation, the whole equation, in terms where you get x minus 1 as a factor in itself. So what do they do is you can write this as x cube minus x square minus 22x square. It will still be 23x, and this can be split as 120. Yeah, 22. So if you do, let me show you rough working here. 142 minus 22, you will be left with 120, which matches with this, right? So it will be 120. I missed a 22. Yeah, plus 22x plus 120 x minus 120. Now I'll take x, I want x minus 1 as a bracket, so x common x minus 1, x square common x minus 1, then minus 22 common x square minus 1, minus 22 x common x minus 1. Right, 120 common x minus 1. So I've got x minus 1 as one of the factors. I'll take it outside. I'm left with x square minus 22x plus 120 as my other bracket, right? So now this I'm going to split the middle term and find the remaining 2 zeros. So in case you are given a quadratic, this is how you proceed. This question is there in the workbook, but it's in level 3. And only one is there as an example. Why do we need to take factors of 120? Okay, Puneet, we need to start somewhere, right? There are 3 zeros for this equation, right? So the easiest way is to take factors of the constant term and do trial and error, so you get 1 0 without doing much work. And for the remaining, now for this bracket which I'm left with, you can do splitting the middle term for x square minus 22x plus 120, right? For this, you don't need to do trial and error method. Again, you can do that. Or what you can do actually is also, in this case, Aditya Mundra, You can take this down if you want. Somebody asked a doubt if they are given such kind of questions what to do, so I was solving it. Okay. Uh, there are two ways of solving. Yeah, Puneet, there are multiple ways of solving. This is one of the ways. The other way is if you actually continue doing trial and error, you might encounter all the three zeros, right? So it depends. You should know. Like if you actually take up 2 here, right? If you take up the factor 2 here, you might get the other 0. If there are more. So we don't know which one it's going to be. Yeah, there are multiple ways of doing the question. I'm not saying do it using this method only. This is one of the method. Atharva, how will you do splitting the middle term in this case? The highest degree of x is 3, not 2. Splitting the middle term works when the highest degree is 2. That's why we did all this, so that we get an expression in the highest degree of 2. Okay, this I just solved it because one of you asked that how do you do when you get such problems. So yeah, don't worry. You can solve the entire thing by using just trial and error method too. Okay, if you know which, there is a, if you can figure out the trick that which can be the factors. Yeah, Raghav, you have a question? Okay, sure. Have you raised your hand? Yes, tell me.
Ma'am, can't we divide x minus 1 from x cube minus 23 square, x square plus 143 x minus 120? We can just divide it and get the same thing in one step.
Yeah, but for that you need to know that you need to divide by x minus 1, right? How will you know what you need to divide it by?
Ma'am, we already found that x minus 1 is a factor in the earlier step, so we can just divide it from there and get the factors. Step
Yeah,
for the
you can do
factor.
that. You'll get some kind of an quotient and you might get the remainder as 0. So
Yeah,
the
the
quotient
quotient
can
will be
then
x
split.
square minus 22x plus 120.
Yeah, then you can split the quotient and get the factors.
Yeah.
That is a, yeah, you can do that. Puneet, you also have a doubt? Puneet's hand is raised. Yes, Puneet.
Yeah, ma'am.
Yes.
So, ma'am, like, what if we first do not follow the factor theorem and and in the start only first we do grouping, like you have done in this second part, and we solve it then.
Uh, yeah, I think that will also be okay. If you, as long as you know, like there are multiple ways of doing this. Whichever way you feel convenient is, whichever is easy, or whichever you know you're not going to make errors.
So, will it work for all this grouping and then splitting?
Yeah, but so in this case, x minus 1 was a factor. It might not be true for all. So there might be cases where some higher number is a factor. So you should be able to figure that out. If you are able to do that, it's, yeah, you can use grouping. Okay, Ria is asking this type of questions won't be asked. Yes, the probability is very low because it involves too much solving. Like, even if you use this method, it is time consuming, right? To check which factors are there. And secondly, this comes under a higher order level question, right? It is a kind of a HOTS question or a exemplar level question. I don't think it may come. But in case it comes, I have shown you how to do it, so don't get blank. Okay, if you just solve, you can use, for all those of you who are not comfortable with other methods, you can try following the method I just showed you. And the others, if you have your own way of solving, you can do that. No worries. But as long as you get the right answer. And like I said, this whole question can also be solved using just by trial and error method. Okay? So that is also open. Okay, so yeah, who had a question? I think Mansi had a question. Mansi, is your doubt clarified? Did you get it? How to solve? Yeah, awesome. Okay, so this was factor theorem, right? Right, and yeah, this also covered our second part, which is grouping, like splitting the middle term. So I don't need to explain, or should I just do a quick recap? Okay, all I'll do is I'll just write it quickly, and then we. Okay, so this will be, I guess, the seventh one, where you factorize by splitting the middle term. Correct? So in this case, what do you do? If suppose it's ax square plus bx plus c, you first write it as ac, right? You get ac, and then you find factors of ac and write it in such a way that it is write b in such a way that it equals to ac. Write b as sum, or what do you say, subtract. Write b sum or subtract to get ac, right? Simple, right? I think most of you are familiar with splitting the middle term. Should I take it up? Let's take this one only, 2x square plus 7x plus 3. Example, 2x square plus 7x plus 3. So first step, write AC, which is what is in this case 2 into 3, 6. Right? So now I'm going to write 7 in such a way that it gives me 6. How do you do that? So either you write something plus something giving you 7. In this case, what are the combinations? 3 plus 4 can give you 7. 5 plus 2 can give you 7. But none of them will give you 6 if you multiply. 7 and 1 will give you 7, right? 7 minus 1. Oh wait, I made a mistake. This won't be like this. It will be, what do you multiply that you get 6, right? So 7 into 1 will 7 minus 1. Let me just write it here instead of confusing you. So in this case, it's basically 2x square plus 7x minus x plus 3, which will give you, uh, 6. 7 minus 1 is 6, right? And 7 into 1 is 7. So it will be, wait, or what are the other factors which can be possible? Uh, yeah, I made a mistake. It's not 7 and 1. It will be, I'm only getting confused. Just give me a sec. Okay. Yeah, so you get the factors of 6, right? Which give you 7. So just write 6 into 1 is 6. 2 into 3 is 6, right? Which of these will give you 7 on addition is 6 plus 1, right? So I'm sorry, I got a bit confused myself. Plus 6x plus x plus 3, right? This will give you 7. 6 plus 1 will give you 7. So 2x x plus 3 plus 1, x plus 3. Then x plus 3 is common, so you take it out, 2x plus 1. Yep. Yeah, the factors are 6 and 1. Yes. Yes, Netri. Yes, Elena. Yes, Puneet. Yes. I got a bit confused myself, so sorry for that. Shakti has a question. Yes, you can raise your hand. I'll unmute you. Yes, Shakti, tell me.
So ma'am, like after you get the factors and everything, you just have to assume, right?
Assume as in?
Like x plus 3, like how do you know it's x plus 3? You have to assume, right?
How do I know? No, there's a systematic way. So first you get this AC. So once you get 6, you find out the factors which will give you B. So which out of this 2 and 3, if you add, will give you 5, or if you subtract, will give you 1, right? 3 minus 2, 1, or minus 1, right? And 6 and 1 will either give you 5, or if you add, will give you 7. So you will get it among one of these. That's why we take 6 and 1, because it gives you 7. So you're just writing 7x as uh, 6x plus x so that you can factorize it. So there's no as such assumption involved. Raghav, you have a question? Yes, Neki, I am yet to cover that. That will be the last part I'm going to cover. No, okay. Okay, this is clear, right? Sorry, I got a bit confused in between. So what do? Factorize by splitting the middle term is basically you write first you write it in terms of AC, right? If this is a general form, find AC, the coefficient of x square and the constant, that product. So here is 6, right? So that product, you find the factors. Find factors of 6 and write them in such a way, write the factors in such a way that you get back B. Okay? So in this case, 6 and 1 gives you 7. That's why we've taken 6 and 1. Okay. Okay, so now we are moving on to the last part of the chapter, the last kind of questions we come across, which is identities. How good are you all with identities? By hearted them, quite good, no, read to see. How good are you all? Identities are basically nothing but a plus b the whole square, a minus b the whole square, a square minus b square. Should I write them down? Okay, I'll quickly write them down. Your job is to write the entire expansion in your notebooks. Okay, I'm just writing the terms. You need to expand it yourself. Write it along with the expansion. So these are the important ones we are going to come across. A square minus b square. Then there is a plus b plus c the whole square. Then there is, this is an interesting one. A minus b the whole cube, right? Yeah, he has given us. He made you all right. Now, good, good. So you've covered all these things. Nice. So make it a point to write them at least once per day. Without looking. When you keep writing it daily, you will get the hang of it. So by 2-3 days, you'll be able to write them without seeing. First initial days, see and write so that you don't make a mistake. But then you need to memorize these. There is no way out. You need to memorize this. This comes handy later on too. So Okay, I'm not writing all of them. There are yeah, there are more. I have not written all of them. Since you all said sir covered them, so I'm not writing them. Right? He covered them, right? So you know which are the important ones. So you just memorize them. You can memorize them by writing down every day, at least once per day. Make it like a thing you do. Okay, that's how you get the practice of memorizing it. Okay, so identities. One of you has a question, is asking me. Yeah, so ma'am, the question will come only solve when we would have to use identity. So, okay, yeah, so again, they might be both types. So sometimes they might say solve using identities, like there are questions here. I'll show it to you. So there are questions here which just say, yeah, evaluate the following products without multiplying directly. What does that mean? That basically means use identities to find the answer. Okay, or you might get questions like which are there in level 1, which are like, where is it? Write the following cubes in expanded form. They might be direct. The direct ones will come for like 1 or 2 marks only. The indirect ones will come like write the following cubes in expanded form, write 3a plus 4b plus 5c square in expanded form. Be careful when you are writing that. Use suitable identities to find the following products and the type of question. Mm, what else is there? Factorize the following using suitable identities. Yeah, so this also comes under factorization only, but you use identities. Right? So we have actually covered most of the important questions in the previous classes, right? So what you all can do is take up the remaining ones, remaining NCRT and exemplar questions, try to solve them, and in case you all have any doubts, you can always ask on the group, right? To write, Shakti has a doubt. To write in expanding form, do we solve the question or just substitute and leave it there? So ideally, you need to substitute and you need to, get it to the form where you can, the simplest form basically. So don't just substitute and leave it there. Try to solve it further till you get the simplest form. Like in this question, this one here, evaluate the following products without multiplying directly. So what do you do? Evaluate the following products is like, it's like 103 into 107. So you can write it as 100 plus 3 and 100 plus 7. That's, you need to solve these kind of questions. Only with practice you will come to know which identity to use where. Okay, so with practice it will come. Just keep solving as many questions you find on using identities. Slowly. First maybe try to do it yourself. If you are stuck, try seeing the solution once and solving, and still you feel that a bit more less confident, maybe you can solve it later once more without C. So you write it like this. Then there is an identity which says this identity. Let me write it with this pen. It says x plus a, x plus b is nothing but x square plus a plus bx plus ab. So I'm going to use this identity here. So what do I get? I get 100 square plus 3 plus 7 into 100 plus 3 into 7. So I need to solve this completely. It will be plus 21 into 100 plus, okay, this is supposed to be a plus. Okay, finally we just. plus 21. Yeah, so when you add this, you will get something like, yeah. So you solve it till here. You don't just substitute and leave it. So always solve it till you get simplest form. Ma'am, it is 10. What is 10, Arav? Yes, Raghav. It was x plus a and x plus b. Yeah, so those 8 identities, make it a point to write every day. Okay. Yeah, so this covers almost all of them. What I'll do is I'll quickly just write them down here. This type of questions. Okay, yeah, so maybe this answer is not right. It will be 1, 2, 1, 2, 1, right? This will be the answer. Okay, so what I'll do is I'll quickly write down what are the types of 7 plus 3 into 100. Okay, yeah, it's not 21. Sorry. Sorry, my bad. Thank you, Raghav. Thank you, somebody. No, not. Give me a second. Yeah, thank you, Arav. So this is 10. So it will be 1000, right? So, okay, whatever the answer comes here. Now you guys calculate and write it down here, right? I have made a mistake. It's 7 and 3. It's 11021. Correct. So basically you got the hang of it, what I'm saying. So I'm just going to quickly write here the different types of problems you're going to get, and I hope you have noted it down, and I hope it comes in handy when you try to solve the questions from the workbook now. So first one is identifying whether it is a polynomial. Right. Second one is degree. Third one is zero of a polynomial. Now I hope when I'm writing these names, you are, recollecting how to solve each one of them. Then next one will be long division. Long division, right? How do? You remember, recollect. Next is remainder theorem. After that, you get factor theorem. Remainder theorem and factor theorem are almost similar. Yes, you remember this? This is just like a recap of what all we covered today. And after that is factor theorem. Then factorizing using factorize by splitting middle term, and the last one is identities. So these are the different types of questions you might get from this chapter, right? So what is your task going to be is, out of these topics, whichever topic you feel you are weak or you feel not confident, like most of you who are having problems with identifying whether it's a polynomial and long division, right? Remainder theorem, factor theorem, I think you all are quite good at it. So first two topics, identities and factorizing using factor theorem, like trial and error method. Practice some sums on that. Okay. Do you want me to assign sums as homework, or will you all solve by yourself? Those of you who have exams, do you want me to assign the different types of questions you'll solve? Okay. If you have any doubts, let me know, right? Or let others know. Let somebody know. Okay, I'm expecting you all to solve. Okay, I hope you are going to solve. So these are the different types of questions, like different categories of questions which will come, and I have told you the simple shortcuts way of solving them, right? So I hope you keep this in mind and solve. So tomorrow we'll take up number systems, and so if you have any doubts in number systems, or if there is anything in particular you want me to cover, let me know, right? Tomorrow let me know that. Okay, and solve. The ones who have exams, please solve these different types of questions. Okay, you can leave. Bye bye. Bye bye. Thank you. Bye.